Welcome back again and thank you for joining me. We're looking at example number 7 in the derivatives lesson. This time we're trying to find the equation of a tangent line to the function gx equals 4x minus 8 root x at x equals 16. So let's read this question a little bit more slowly. So we're trying to find the equation of a tangent line. So which means that we're trying to find the equation of some line which should be in the form y equals mx plus b. So this line represents the tangent drawn to the graph of the function gx equals 4x minus 8 root x. We're drawing this tangent line at x equals 16. So the information we know about this tangent line is that x would be equal to 16 and the value of y would be equal to the value of the function at 16. So that would be g of 16. And g of 16 is equal to 4 times 16 minus 8 root 16. So 4 times 16 is 64, 8 root 16 is 32, so that would be equal to 32. So let's take a look at the rest of the letters in the equation. Check and see what else we can find or what else we have. So we got y, we got x. We don't have the b value or the y-intercept, but we can figure out what the slope is. Recall that the slope is also described as the derivative of the function. And since we're drawing the tangent at x equals 16, we'll say that the slope would be g prime at 16. So in other words, to find the slope, we need to find g prime. So we'll start off by finding the derivative of gx. And I will rewrite the function gx since we have radicals involved. And I'll write every term in power form so I can use the power rule. So that would be 8x to the power of 1/2, which means that g prime x would be equal to derivative of 4x is 4, and derivative of 8x to the power of 1/2, we have 8 in here. 1/2 will become a coefficient x to the power of half minus 1. So that will make it 4 minus. 8 and 2 will simplify to a 4. X to the power of half minus 1 is negative half. So that means that the derivative g prime x, which will describe the rate of change or the slope of the tangent at any point x, is 4 minus 4 over the square root of x. So I'm bringing the square root in the denominator, or the power of negative 1 over 2 in the denominator, so it turns into a positive number. Now remember that the slope in our case was equal to the value of the derivative at 16. So we'll replace x by 16. So we have 4 minus 4 square root of 16, or 4 minus 4 over 4, which equals 3. So therefore, we're going to say that the slope equals 3. So now we know that the y value is 32. I'll continue writing it here. The slope is 3 at the x value of 16, and b is still unknown. So to find the value of b, we simply solve for b. We have 32 equals 48 plus b. So 32 minus 48 equals b, which means that the value of b equals negative 16. So therefore, we'll say that the equation of this line is y equals 3x minus 16. So the tangent drawn in slope y-intercept form would be y equals 3x minus 16. If you were to ask or to write this equation in standard form, we simply take all the terms to one side of the equation. I'll take them all to the right side. 3x minus y minus 16. We'll say this equals 0, but obviously if you write 0 on this side or on this side, it won't really matter. So there we go. This would be the standard form of the tangent of the equation of the tangent line. In the next example, we have to find the points where the tangents are horizontal given the function gx equals negative x cubed plus 3x squared minus 2. So let's look into every piece of information here carefully. So we have to find the points. So we have to find coordinates of points, so the x and the y, on the graph of a function where the tangent line is horizontal. A horizontal tangent translates to slope equals 0 lines. Remember that tangents are straight lines. When they're horizontal, when lines are horizontal, their slopes are 0, which tells us that the derivative of this function must be 0 for these particular lines, which are the tangents. So what that means is that we have to start off by finding the derivative of function gx. So g prime x equals negative 3x to the power of 2 plus 6x. That must be equal to 0. So we solve this by simply factoring. It's easier because both terms contain x. So negative 3x is a common factor, and we have x minus 2 equals 0. Negative 3x equals 0 when x equals 0, or x minus 2 equals 0 when x equals 2. So what that means is that there will be 2 points at which the tangent will be horizontal. So one would be at x equals 0 and one at x equals 2. Since we're asked for the points, we need to find the corresponding y values, which would be found by simply substituting the value of x into the function. So negative 0 to the power of 3, 3 times 0 squared minus 2, and that would equal negative 2. Therefore, the tangent drawn at 0, negative 2 will be horizontal. And similarly, we're finding the y value at x equals 2 as g of 2, which is negative 2 to the power of 3 plus 3 times 2 squared minus 2. That would equal negative 8 plus 12 minus 2, which is positive 2. So therefore, the next point where the tangent will be horizontal is at 2 and 2. So these are the answers to this question. So the points are 0 and negative 2 and 2 positive 2. So in the next example, which is the last example for this lesson, we are asked to determine whether the function f of x equals 2x cubed plus 30 over x cubed plus 4 is increasing, decreasing, or not changing at x equals negative 2. So recall that when we graph the function, or when we graph any function, so, and I'm going to take here as an example a curved line, some polynomial function, I would say. This is not a polynomial function, by the way. This is a rational function. So we said that if the slope of the tangent is positive, it means that the function is increasing at a point. If the slope of the tangent is negative, it means the function is decreasing. And if the slope of the tangent is constant or constantly 0, it means that the function is not changing at that point. So the 3 scenarios are the following: positive slope, negative slope, and 0 slope. So which means increasing function, decreasing function, and not changing. So if we want to determine what happens at x equals negative 2, it is enough that we find the slope of the tangent at x equals negative 2, or should we say the derivative of the function at x equals negative 2? So let's get started then by finding the derivative f prime x. Now, since this function has x in the denominator, and we only know the power rule so far, what we're going to do is first rewrite the function f of x with all the terms in power form. So we have 300, x will come to the numerator, the power negative 3 plus 4. So the derivative will be 2 times 3x squared plus 300 times negative 3x to the power negative 4. And we know the derivative of 4 is 0, so we don't need to write that. So f prime x equals 6x squared minus 900 divided by x to the power of 4. So at x equals negative 2, the value of the derivative will be 6 times negative 2 squared minus 900 divided by negative 2 to the power of 4. So that would be equal to 6 times 4, 24 minus 900 divided by 16. Yes, 16. Goodness. So 24 minus 900 divided by 16 would be equal to in fraction form, actually, negative 129 over 4. I did this by using the calculator here behind the screen. You can see that this is a negative number, which tells us that the rate of change of the function at x equals negative 2 will be negative, which means that the function g of x at f of x at negative 2 will be decreasing. So these were the examples that we wanted to discuss for the derivative of a function. And in the next section, which I called an extension to derivatives, we want to discuss the differentiability of a function. So I will see you next time. Thank you for watching. Bye for now.